Universal Serial Bus, otherwise known as USB, technologies allow the rapid transfer of data from one device to another. The USB standard was designed through a jointed effort of 7 of the largest companies in the computing and electronics industry. USB connections were designed to replace some of the serial and parallel connections previously created. We can see that it has continued to evolve to meet the needs of manufacturers and consumers. USB devices generally features plug-and-play functionality. Sometimes we see USB computer connections can also serve to charge devices using the onboard power source of the computer system.
Versions of USB. USB 1.
The initial release of the USB standard in November of 1995 had considerable flaws. It called for data rates of 1.5 megabits per second for low bandwidth applications and 12 megabits per second for full bandwidth usage. It was not until the release of USB version 1.1 that USB technologies became widely accepted in the US. The first USB devices were limited to keyboards and joysticks, but as the USB format became more popular, a wider range of devices began implementing this standard.
USB 2.
The second version of the USB standard was introduced in 2000 and represented an advance in speed and superiority. A higher level of bandwidth was supported that was faster than before. This upgrade allowed data transfers of up to 60 megabytes per second and paved the way for higher speed file transfers along with a number of new connector formats such as Mini-A and micro USB cables and connectors.
USB 3.
Released in 2008, USB 3 is the fastest and most advanced standard for data transfer with speeds up to 625 megabytes. The standard is designed to be compatible with USB 2.0 and to allow upgrades for newer advances in USB technology. USB 3 consumes less power and can be used with high-definition video systems. These high-end electronic devices perform better with USB 3.0 than the previous version and take advantage of the higher bandwidth and fast speed of the USB 3 interface. As you can see, when comparing USB 2 to USB 3, there are significant design changes. This allows for the higher rate of transfer. In this image you can see that there is a fifth prong in the USB 3.0.
Interface types.
Physical connectors are used in order to allow devices to interface using the USB protocols. We know them as male or female. Interface types include
Standard A.
Along with the standard B connector, this connector type was introduced with the release of USB 1.1 and continues to be the most common type of USB plug on the market. It is designed to fit into a computer or hub port and to transfer data and electricity simultaneously, allowing devices to charge while in use.
Standard B.
This connecting plug also provides power and data transfer simultaneously, but usually fits into a device port rather than a computer port.
Mini-A and Mini-B.
The increasingly popular use of cell phones and devices prompted the creation of Mini-A and Mini-B to fit these smaller devices.
4-prong Mini.
These specialized USB connectors have mostly been abandoned in favor of the newer micro USB interfaces.
Micro USB.
Available in A, B, and AB varieties, micro USB connections are rapidly becoming the industry standard and are compatible with a wide range of newer digital and personal computing and communications devices.
A bit about USB conversion.
USB to serial adapters come in several different variations in regards to interface types. The most commonly used interface type is serial RS-232. Other frequently used interfaces are RS-485 and RS-422. Regardless of which interface type the adapter it has, it usually looks the same, with the one difference that RS-232 adapters usually have a DB9 connector for connecting to the serial device, whereas the RS-485 and RS-422 adapters usually have a screw terminal header for connecting a serial device.
Thanks for watching.